Dear students, in our previous classes we have discussed the inverse trigonometric functions and some of their properties. For example, we have discussed the existence of inverse trigonometric functions, their domain and range, and formulae with their proof and some examples. In this class, we will discuss some more properties and problems on it. The properties like 2 sin inverse x, 2 cos inverse x, 2 tan inverse x, 3 sin inverse x, 3 cos inverse x, 3 tan inverse x and their proofs. Properties means basically formulas. So, let us discuss the 2 sin inverse x. 2 sin inverse x is equals to sin inverse 2x into root over of 1 minus x square. Condition is minus 1 by root 2 less than equal to x less than equal to 1 by root 2. Pi minus sin inverse 2x into root over of 1 minus x square 1 by root 2 less than equal to x less than equal to 1. Minus pi minus sin inverse 2x into root over of 1 minus x square minus 1 less than equal to x less than equal to minus 1 by root 2. So, let us prove for one case, that is when x lies between minus 1 by root 2 to 1 by root 2. Let alpha is equals to sin inverse x. Let alpha is equals to sin inverse x. Alpha is equals to sin inverse x implies x is equals to sin alpha, and you know alpha lies between minus pi by 2. Alpha lies between minus pi by 2 to pi by 2. Alpha lies between minus pi by 2 to pi by 2. If x is equal to sin alpha, so cos alpha will be root over of 1 minus x square, 1 minus sin square alpha, so 1 minus x square. See, since alpha lies between, alpha belongs to minus pi by 2 to pi by 2, so cos alpha is positive. If alpha lies between minus pi by 2 to pi by 2, cos alpha is positive. So, take sin 2 alpha. Sin 2 alpha is your 2 sin alpha into cos alpha, right? 2 sin alpha into cos alpha, which is equal to 2x into root over of 1 minus x square, because sin alpha x, cos alpha root over of 1 minus x square. But given that, let x lies between minus 1 by root 2 less than equal to x less than equal to 1 by root 2. Here given that, given condition is your x lies between minus 1 by root 2 to plus 1 by root 2. That is minus 1 by root 2, I can write sin of minus pi by 4 less than equal to sin alpha less than equal to sin pi by 4, less than equal to sin pi by 4, as sin is. So, in this case minus pi by 4 less than equal to minus pi by 4 less than equal to alpha less than equal to pi by 4, because sin is increasing function, sin is increasing. So, this implies multiply 2 minus pi by 2 less than equal to 2 alpha less than equal to pi by 2. So, 2 alpha lies between minus pi by 2 to pi by 2, that is our condition. So, sin 2 alpha, now you can write sin 2 alpha is equals to 2 sin alpha into cos alpha, which is equals to 2x into root over of 1 minus x square. Now 2 alpha is equals to sine inverse 2x into root over of 1 minus x square. So put alpha is equals to sine inverse x. So sine inverse x is equals to sine inverse 2x into root over of 1 minus x square. Right? So now the proof is over. So for the condition minus 1 by 2, x lies between minus 1 by root 2 to plus 1 by root 2, 2 sine inverse x is equals to sine inverse 2x, sine inverse 2x into root over of 1 minus x square. So similarly, the formula for 2 cos inverse x, 2 cos inverse x is equals to cos inverse 2x square minus 1 provided 0 less than equal to x less than equal to 1, and a 2 pi minus cos inverse 2x square minus 1 less than equal to x less than equal to 0. So the same proof you can prove by taking alpha is equals to cos inverse x. So x is equals to cos alpha. Alpha lies between closed interval of 0 to pi, because you know cos inverse x, x lies between minus 1 to 1 and alpha lies between 0 to pi. Now cos 2 alpha is equal to 2 cos square alpha minus 1. You can see in your screen also, cos 2 alpha, 2 cos square alpha minus 1. So put cos alpha is equals to x, that is 2x square minus 1. So take one case, that is x lies between 0 to 1, 0 less than equal to x less than equal to 1, implies 0 less than equal to alpha less than equals to pi by 2, because x is your cos alpha. So since x is cos alpha, so 0 less than equal to cos alpha less than equal to 1 implies 0 less than equal to alpha less than equal to pi by 2. So multiplying 2 both sides, we get 0 less than equal to 2 alpha less than equal to pi, that is 2 alpha lies between 0 to pi. So from equation 1 we get cos 2 alpha is equal to 2x square minus 1. So 2 alpha is equals to cos inverse 2x square minus 1, that is put alpha is equals to cos inverse x. So 2 cos inverse x is equals to cos inverse 2x square minus 1. So similarly you can prove the other case, minus 1 less than equal to x less than equals to 0. I have proved for 0 less than equal to x less than equal to 1, 2 cos inverse x is equals to cos inverse 2x square minus 1, right? So next property is your for 2 tan inverse x. All properties means all formulae, that formula for 2 tan inverse x, tan inverse 2x by 1 minus x square minus 1 less than x less than 1 pi plus tan inverse 2x by 1 minus x square for x greater than 1 minus pi plus tan inverse 2x by 1 minus x square for x less than 1. So consider one case, that is for x less than 1, x less than minus 1. Out of the 3 cases, we have to prove the formula for 2 tan inverse x for x is less than minus 1. So when x less than minus 1, tan alpha is your, so consider this case, x less than minus 1 and x is equals to, and alpha is equals to tan inverse x. So now tan alpha less than minus 1, because x is your tan alpha and minus 1 is your tan alpha less than minus 1. So this implies minus pi by 2 less than alpha less than pi by 4, less than minus pi by 4, less than minus pi by 4. So multiplying 2, minus pi less than 2 alpha less than minus pi by 2. So 2 alpha lies between minus pi less than 2 alpha less than minus pi by 2. This implies 0 less than pi plus 2 alpha less than pi by 2. adding pi both sides. Here adding pi both sides we get this one. Now pi plus 2 alpha lies between 0 to pi by 2. Next use the formula tan 2 alpha is equals to 2 tan alpha by 1 minus tan square alpha, which is equals to 2x by 1 minus x square. So 2 alpha is equals to, so use the formula tan 2 alpha is equals to 2 tan alpha by 1 minus tan square alpha, which is equals to 2x by 1 minus x square. So this implies tan pi plus 2 alpha is equals to 2x by 1 minus x square, 2x by 1 minus x square. Now pi plus 2 alpha is equals to tan inverse 2x by 1 minus x square, 2x by 1 minus x square. Now take pi on that side. So you get 2 alpha is equals to minus pi plus tan inverse 2x by 1 minus x square, right? So 2 alpha is your tan inverse x. 2 tan inverse x is equals to minus pi plus tan inverse 2x by 1 minus x square. So you get the formula. So for x less than minus 1, I have proved that 2 tan inverse x is equals to tan inverse minus pi plus tan inverse 2x by 1 minus x square, right, for x less than minus 1. Similarly, you can prove it for other cases also. Means for x greater than 1, you can write 2 tan inverse x is equals to pi plus tan inverse 2x by 1 minus x square, and when x lies between minus 1 to plus 1, 2 tan inverse x is your tan inverse 2x by 1 minus x square, right. So you have the formulae for 2 sin inverse x, 2 cos inverse x and 2 tan inverse x, right. Now consider another property, that is another formula, 3 sin inverse x, 3 cos inverse x and 3 tan inverse x. Let us first discuss 3 sin inverse x, right. So 3 sin inverse x is equals to sin inverse 3x minus 4x cube, provided minus 1 by 2 less than equal to x less than 1 by 2, pi minus sin inverse 3x minus 4x cube 1 by 2 less than equal to x less than equal to 1, and minus pi minus sin inverse 3x minus 4x cube minus 1 less than equal to x less than equal to minus 1 by 2. So out of the 3 cases, I am proving by taking one case. Let us prove for one case, that is suppose say 1 by 2 less than equal to x less than equals to 1, right. So take the case when x lies between 1 by 2 to 1, that is for the case x lies between 1 by 2 less than equal to x less than equals to 1, right. Let alpha is equals to sin inverse x or x is equals to sin alpha. You know alpha belongs to minus pi by 2 to pi by 2, that is the range value. Next sin 3 alpha. Sin 3 alpha, 3 sin alpha minus 4 sin q alpha, that is 3x minus 4x cube, right. So now take the condition. What are the condition? The condition is 1 by 2 less than equal to x less than equals to 1. So we are taking this condition for x lies between minus 1 by 2 less than equal to x less than equal to 1. This implies 1 by 2 less than equal to x is your sin alpha less than equal to is your 1 So alpha lies between pi by 6 less than equal to alpha less than equal to pi by 2. So multiplying 3, that is pi by 2 less than equal to 3 alpha less than equal to 3 pi by 2. So now minus pi by 2 less than equal to 3 alpha minus pi less than equal to pi by 2, because lies between minus pi by 2 to pi by 2. So now you can use sin pi minus 3 alpha is equals to sin 3 alpha, which is equals to 3x minus 4x cube. So pi minus 3 alpha is equals to sin inverse 3x minus 4x cube. Now pi minus sin inverse, take this side, sin inverse 3x minus 4x cube is equal to 3 alpha, which is equal to 3 sin inverse x. So we have proved by taking the case. So we have proved the formula for 3 sin inverse x for different conditions, but I have proved only for one condition, right? So let us take the formula for 3 cos inverse x. 3 cos inverse x, cos inverse 4x cube minus 3x, condition is your 1 by 2 less than equal to x less than equal to 1, and 2 pi minus cos inverse 4x cube minus 3x minus 1 by 2 less than equal to x less than equal to 1 by 2, and 2 pi plus cos inverse 4x cube minus 3x minus 1 less than equal to x less than equal to minus 1 by 2. Remember all the conditions and formula, corresponding formula for it. So let us take the case for where x lies between 1 by 2 to 1, that is 1 by 2 less than equal to x less than 1. So similarly the other cases can be proved, right? So take alpha is equal to, let alpha is equals to cos inverse x, right? Take this case, that is 1 by 2 less than equal to x, 1 by 2 less than equal to x less than equal to 1. So take alpha is equals to cos inverse x. So x is equals to cos alpha, where alpha belongs to 0 to pi. Alpha lies between 0 to pi, that is cos 3 alpha is equal to 4 cos cube alpha minus 3 cos alpha, which is equal to 4x cube minus 3x. Cos, use the formula cos 3x. So take the case 1 by 2 less than equal to x less than equal to 1. So if you take this case, so write for 1 by 2, write cos pi by 3 60 degree less than equal to x is your cos alpha less than equal to cos 0 degree 1 cos 0 degree. So this implies 0 less than equal to alpha less than equal to pi by 3. Alpha lies between 0 to pi by 3 because alpha is decreasing function. So if the inequality here is less than equal to, automatically for decreasing function it is greater than equal to, means this less than alpha less than 0. So for condition 0 less than alpha less than pi by 3, that is the formula for decreasing functions. Cos is decreasing in 0 to pi. So multiply 3 here, that is 0 less than equal to 3 alpha less than equal to pi. Now 3 alpha lies between closed interval of 0 to pi. So we can use this formula, cos 3 alpha is equal to 4x cube minus 3x. So 3 alpha is equals to cos inverse 4x cube minus 3x, right? So put alpha is equals to cos inverse x. So 3 cos inverse x is equals to cos inverse 4x cube minus 3x. So this is the formula for the condition 1 by 2 less than equal to x less than equals to 1. So you can prove other cases like that one. You can also prove for other cases. Now take the property or formula for 3 tan inverse x. 3 tan inverse x, tan inverse 3x minus x cube by 1 minus 3x square. Condition is minus 1 by root 3 less than x less than 1 by root 3. Pi plus tan inverse 3x minus x cube by 1 minus 3x square x greater than 1 by root 3, and minus pi plus tan inverse 3x minus x cube by 1 minus 3x square x less than minus 1 by root 3. These are the conditions. Correspondingly the formula is given, right. So take the case second one, that is x greater than 1 by root 3. So for x greater than 1 by root 3, tan alpha greater than 1 by root 3 is your tan pi by 6. So when x greater than 1 by root 3, tan alpha greater than tan pi by 6, because x tan alpha and 1 by root 3 is your tan pi by 6. This implies alpha greater than pi by 6, because tan alpha is increasing. So tan alpha greater than tan pi by 6 implies alpha greater than pi by 6. So pi by 6 less than alpha less than pi by 2, because it is we are taking minus pi by 2 to pi by 2. So pi by 6 less than alpha less than pi by 2, multiplying 3 both sides, that is pi by 2 less than 3 alpha less than 3 pi by 2. So taking minus pi both sides, so pi minus pi, adding minus pi both sides, that is minus pi plus pi by 2 less than 3 alpha minus pi less than 3 pi by 2 minus pi, that is minus pi by 2 less than 3 alpha minus pi less than pi by 2. Now the next one is your, that is your 3 alpha minus pi lies between minus pi by 2 to pi by 2. We have proved or we have discussed that 3 alpha minus pi lies between pi by 2 to minus pi by 2. We have discussed this one. So now tan 3 alpha minus pi is your minus tan pi minus 3 alpha, because take minus here. So tan of minus theta minus tan theta, but you know tan of pi minus 3 alpha minus tan 3 alpha. So minus of minus tan 3 alpha, that is equals to tan 3 alpha. Now use the formula, tan 3 alpha is your 3 tan alpha minus tan q alpha by 1 minus 3 tan square alpha, right. So now this one is your 3x minus x cube divided by 1 minus 3x square, 1 minus 3x square, that is tan 3 alpha minus pi, right, tan 3 alpha minus pi. So this one also tan 3 alpha minus pi. Now 3 alpha minus pi is your tan inverse, this one 3x minus x cube divided by 1 minus 3x square. So take pi on that side, that is pi 3 alpha is equals to pi plus tan inverse 3x minus x cube divided by 1 minus 3x square, that is 3 alpha is equal to pi plus tan inverse 3x minus x cube divided by 1 minus 3x square. So put alpha is equal to this. So 3 alpha is your tan inverse x. So 3 tan inverse x is equals to pi plus tan inverse 3x minus x cube divided by 1 minus 3x square, right? So you have proved that 3 tan inverse x is equals to pi plus tan inverse 3x minus x cube. That is, for different cases you have proved the formulae. So we have proved, so dear students, you have proved the formulae for 2 sin inverse x, 2 tan inverse x, 2 cos inverse x, 3 sin inverse x, 3 cos inverse x, 3 tan inverse x, right? And they are proved for different cases. And in the next class we will discuss some problems. So let us now work out some problems. Let us first consider 2 tan inverse x. We have expressed 2 tan inverse x in terms of tan inverse something. 2 tan inverse x, you can use 2 tan inverse x is equals to sin inverse 2x by 1 plus x square minus 1 less than equal to x less than equal to 1, pi minus sin inverse 2x by 1 plus x square x greater than 1, minus pi minus sin inverse 2x by 1 plus x square x less than 1. So take one case when x greater than 1. When x greater than 1, you are taking alpha is equals to tan inverse x. So tan alpha greater than 1 in place of x, tan alpha greater than 1. So tan alpha greater than 1 implies pi by 4 less than alpha less than pi by 2, implies pi by 2 less than 2 alpha less than pi, multiplying 2 both sides. This implies minus pi less than minus 2 alpha less than minus pi by 2. So adding pi both sides, that is 0 less than pi minus 2 alpha less than pi by 2. Now use sin 2 alpha is equals to 2x by 2 tan alpha by 1 plus tan square alpha. Sin 2 alpha is equals to 2 tan alpha by 1 plus tan square alpha. In place of tan alpha, put x. So sin 2 alpha is equal to 2x by 1 plus x square. Now sin pi minus 2 alpha also 2x by 1 plus x square. So pi minus 2 alpha sin inverse 2x by 1 plus x square. So 2 alpha is equals to pi minus sin inverse 2x by 1 plus x square. So in place of alpha, write tan inverse x. So 2 tan inverse x is equals to pi minus sin inverse 2x by 1 plus x square. In the previous formula, you have expressed 2 tan inverse x in terms of tan inverse, but here you can express in terms of sin inverse also. Similarly, in example 2, you can express 2 tan inverse x in terms of cos inverse also. That is 2 tan inverse x is equals to cos inverse 1 minus x square by 1 plus x square, 0 less than equal to x less than infinity, minus cos 1 minus x square by 1 plus x square minus infinity less than x less than 0. So take the case 0 less than equal to x less than infinity. So take the case to 0 less than equal to x less than infinity, and theta take sin tan inverse x, right? So since 0 less than equal to x less than infinity, so 0 less than equals to tan theta less than infinity. So theta lies between 0 to pi by 2. 0 less than equal to theta less than equal to less than pi by 2, less than pi by 2, right? So multiplying 2 both sides, that is 0 less than equal to 2 theta less than pi. You know cos, that is 2 theta lies between 0 to pi. Now use the formula cos 2 theta is your 1 minus tan square theta by 1 plus tan square theta, which is equals to 1 minus x square by 1 plus x square. Now 2 theta is equals to cos inverse 1 minus x square by 1 plus x square, right? So use theta is equals to tan inverse x. Tan inverse x, that is 2 tan inverse x is equals to cos inverse 1 minus x square by 1 plus x square, right? So you have proved the formula for 2 tan inverse x in terms of cos inverse. So consider the problem. One problem is your, if sine of sine inverse 1 by 5 plus cos inverse x is equals to 1, find the value of x. Right? So one problem is your sine inverse 1 by 5 plus cos inverse x is equals to 1. So find the value of x or solve it. So this implies sine inverse 1 by 5 plus cos inverse x is equals to sine inverse 1. So take sine inverse 1 as pi by 2, right? Sine inverse 1 as pi by 2. So this implies sine inverse 1 by 5 is equal to pi by 2 minus cos inverse x. Take cos inverse x on that side. You know one formula is there, I have already told to you. Sin inverse x plus cos inverse x is equals to pi by 2. So pi by 2 minus cos inverse x is equals to sin inverse x, because sin inverse x plus cos inverse x pi by 2. So sin inverse 1 by 5 sin inverse x implies x is equals to 1 by 5. That is the value of x, right? So one problem is how to solve the expression involving inverse trigonometric functions, right? So now find the value of sine of 2 cot inverse minus 5 by 12. We have to find the value of sine of 2 cot inverse minus 5 by 12, right? Okay, so sine of 2 cot inverse minus x is your pi minus cot inverse 5 by 12. Pi minus cot inverse 12. So multiply cot inverse 5 by 12. So multiplying 2 pi minus 2 cot inverse 5 by 12, right? Multiplying 2 both sides. Now which is equal to sine 2 pi minus theta, take this one as theta, is your minus sine 2 cot inverse 5 by 12. Sine 2 pi minus theta is your 2 cot inverse minus sine 2 cot inverse 5 by 12. So now minus sine 2 cot inverse 5 by 12 is your tan inverse 12 by 5, right? 2 cot inverse 5 by 12 is your tan inverse 12 by 5. Now so express this one, minus sine 2 tan inverse 12 by 5. 2 tan inverse 12 by 5 is your pi minus sine inverse. This one is your pi minus sine inverse 2x by 2 into x is your 12 by 5 by 1 plus 1 12 by 5 whole square, right? Because the formula is your 2 tan inverse x is equals to pi minus sin inverse 2x by 1 plus x square for x less than minus 1. Now minus sin pi minus theta. Take this one as theta. So this one is your sin inverse. After simplification, you will get that is 120 by 169. You will get the form. So now which is equals to minus 120 by 169, because sin inverse x is your x, so minus of x. So you have proved that sin inverse x is equal. You have proved the problem, and we will discuss more. So let us discuss some more problems on using the formulae 2 sin inverse x, 2 tan inverse x, 2 cos inverse x, and 3 sin inverse x, 3 cos inverse x, 3 tan inverse x. So let us prove 2 tan inverse minus 3 is equal to minus pi by 2 plus tan inverse minus 4 by 3, right? So use 2 tan inverse minus 3 is equals to minus pi by 2 plus tan inverse minus 4 by 3. Prove this one. It is given that you have to prove this one. So take LHS. So 2 tan inverse minus 3. You know tan inverse minus x is your minus tan inverse x. So 2 tan inverse 3. So here 2 tan inverse x, use the formula. But here x greater than 1. And you know when x greater than 1, the formula is your minus is here pi plus tan inverse 2x 2 into 3 by 1 minus x square, that is 3 square 9. Since here x greater than 1, use the, so the formula is pi plus tan inverse this. I have already discussed. So now minus pi plus minus tan inverse is your minus tan inverse minus 3 by 4. After solving this one, 6 by 8 is your minus 3 by 4. So which is equals to minus pi plus tan of minus x, again minus, so minus minus plus tan inverse 3 by 4, minus pi plus tan inverse 3 by 4. So which is equals to minus pi plus tan inverse 3 by 4 is equal to pi by 2 minus cot inverse 3 by 4, because tan inverse 3 by 4 plus cot inverse 3 by 4 is equals to pi by 2. Now this one is your minus pi by 2, minus pi plus pi by 2, that is minus pi by 2 minus cot inverse 3 by 4. So this one is your minus pi by 2 minus cot inverse 3 by 4 is your tan inverse 4 by 3, tan inverse 4 by 3. Now you can write minus pi by 2 plus tan inverse minus 4 by 3, because tan inverse minus x minus tan inverse x, which is equal to RHS, which is equal to RHS. So you have proved 2 tan inverse minus 3 is equals to minus pi by 2 plus tan inverse minus 4 by 3. So let us evaluate tan inverse 3 sin 2 alpha. So the problem is tan inverse 3 sin 2 alpha divided by 5 plus 3 cos 2 alpha, 5 cos 2 alpha is equals to plus tan inverse 1 by 4 tan alpha. Let us evaluate this one. Means here alpha is your minus pi by 2 less than alpha less than pi by 2. Alpha lies between minus pi by 2 to pi by 2. The question is find the value of tan inverse 3 sin 2 alpha 1 by 5 plus 3 cos 2 alpha plus tan inverse 1 by 4 tan alpha. Let us first simplify this one using the formula sin 2 alpha is equal to 2 tan alpha by 1 plus tan square alpha, and cos 2 alpha is equal to 1 minus tan square alpha by 1 plus tan square alpha. So using these two, first simplify this one. So what is the value? 3 sin 2 alpha by 5 plus 3 cos 2 alpha. So which is equals to 3 into 2 tan alpha by 1 plus tan square alpha divided by 5 plus 3 into 1 minus tan square alpha by 1 plus tan square alpha. Right? So now this one is equal to 6 tan alpha by 1 plus tan square alpha divided by this one is your 5 plus 3 is your 8 plus this one 5 tan square alpha minus 3 tan square alpha is your 2 tan square alpha. 5 tan square alpha minus 3 tan square alpha, that is 2 tan square alpha divided by 1 plus tan square alpha. Now 1 plus tan square alpha, 1 plus tan square alpha cancel out, and the value is your here 6 tan alpha divided by 8 plus 2 tan square alpha. Take 2 common and from the numerator as well as from the denominator. So 3 tan alpha divided by 4 plus tan square alpha. The value of this one is your this one, 3 tan alpha plus 4 tan square alpha. Now put the value here. So tan inverse, this one is your 3 tan alpha by 4 plus tan square alpha plus tan inverse 1 by 4 tan alpha. Right? Now use the formula tan inverse x plus tan inverse y. Tan inverse x plus tan inverse y, which is equals to tan inverse x plus y, that is 3 tan alpha by 4 plus tan square alpha plus 1 by 4 tan alpha x plus y by 1 minus x into y, 3 tan alpha by 4 plus tan square alpha into 1 by 4 tan alpha. Right? So this one. So tan inverse x plus y by 1 minus x into y. Right? So now using or after simplification, so it will take LCM. LCM is your tan alpha by 4. LCM is your 4 into 4 plus tan square alpha. 4 into 4 plus tan square alpha. Now this one is your 12 tan alpha plus 4 tan alpha plus tan q alpha. Right? Tan alpha by 4, 12 tan alpha, 4 tan alpha plus tan q alpha in the numerator. In the denominator, so multiply 16 plus 4 tan square alpha, 16 4 tan square alpha, take LCM. So now minus 3 tan square alpha. Right? So this one is your, now after simplifying, After simplifying this one, you will get a tan inverse. Tan inverse. Here you see 16 tan alpha plus tan q alpha divided by here also 4 plus tan square alpha. Now these two cancel out. So now the remaining one is your 16 tan alpha plus tan q alpha divided by 16 plus tan square alpha, right? So after simplification, you will get 16 tan alpha plus tan q alpha by 16 plus tan square alpha. Now tan inverse, take tan alpha common. So now it's 16 plus tan square alpha divided by 16 plus tan square alpha, right? So these two cancel out. Now it is tan inverse. Now it is tan inverse tan alpha, which is equals to alpha, right? Now the value of tan inverse 3 sin 2 alpha divided by 5 plus 3 cos 2 alpha plus tan inverse 1 by 4 tan alpha, the value is your alpha. So that one is one of the important problem, and let us evaluate tan of 1 by 2 cos inverse root over of 5 by 3. Let us evaluate another problem is your, let us evaluate tan of 1 by 2 cos inverse root 5 by 3. Find the value of this one. So take this one, let cos inverse root 5 by 3 is equals to theta. So cos theta is equals to root 5 by 3. Cos theta is equals to root 5 by 3. Right? Now, so this one is your tan of 1 by 2 theta, means tan of theta by 2. So tan of theta by 2, you can write it as root over of 1 minus cos theta by 1 plus cos theta, because you know 1 minus cos theta is your 2 sin square theta by 2. This one is your 2 sin square theta by 2, and this one is your 2 cos square theta by 2. 2 cancel out, sin square theta by 2, cos square theta by 2 is your tan square theta by 2, and root over is your tan theta by 2. So you can write like this. So now put the value of cos. So 1 minus this one cos theta is your root 5 by 3. So it is your 5 by 9. 5 by cos theta is your root 5 by 3 divided by 1 plus root 5 by 3 whole root over, which is equals to 3 minus root 5 by 3 plus root 5 whole root over. Rationalizing this one, you that is multiplying root 5 minus 3 minus root 5 in the numerator as well as in the denominator. You will get 3 minus root 5 whole square divided by 9 minus 5 root over, multiplying 3 minus root 5 in the numerator as well as in the denominator. The answer is your 3 minus root 5 by 2. This is the value of tan of 1 by 2 cos inverse root 5 by 3. Then express sin inverse root over of 1 plus x plus root over of 1 minus x by 2, where 0 less than x less than 1 in simplest form. Means this is the inverse trigonometric expression sin inverse root over of 1 plus x plus root over of 1 minus x by 2 in the simplest form. So put x is equals to cos 2 theta. Now 1 plus cos x is your 1 plus cos 2 theta. Already I have discussed in the previous problem. 1 plus cos 2 theta root over plus minus root 2 cos theta. and root over of 1 minus x is your root over of 1 minus cos 2 theta plus minus root 2 sin theta, and 0 less than x less than 1 implies 2 theta belongs to closed interval of 0 to pi by 2, that is theta belongs to 0 closed interval of 0 to pi by 4. So cos theta and sin theta both positive since theta lies between 0 to pi by 4. So root over of 1 plus x is your plus minus, it is evaluated but take plus only because sin theta and cos theta positive. So root over of 1 plus x root 2 cos theta, root over of 1 minus x root 2 sin theta. Now it is your root over of cos theta plus sin theta by 2. So dividing we get it is sin pi by 4 plus theta after simplification. So sin inverse root over of 1 plus x plus root over of 1 minus x by 2, sin inverse sin pi by 4 plus theta. So the answer is your pi by 4 plus theta, and pi by 4 plus theta is your 1 by 2 cos inverse x. Next to solve cot inverse 1 minus x square by 2x, which is equal to cosec inverse 1 plus a square by 2a minus sec inverse 1 plus b square by 1 minus b square, right. So cos inverse is your tan inverse 2x by 1 minus x square, and cosec is your sin inverse 2a by 1 plus a square minus cos inverse 1 minus b square. So 2 tan inverse x, use the formula tan inverse 2x, 2 tan inverse x is equal to 2 tan inverse a minus 2 tan inverse b. After cancel out, use the formula tan inverse a minus tan inverse b is equal to tan inverse a minus b by 1 plus ab. So the value of x is your a minus b by a plus b. Similarly, you can evaluate sin of 2 sin inverse 0.8, right. Use the formula 0.8 less than it is 1. So pi minus sin inverse this, you will get 0.96. So dear students, this is all about the inverse trigonometric functions. I have already discussed all the properties and work out maximum number of problems for this chapter, and this is your in your unit 1. I think and I hope you will succeed and practice all the problems. Thank you.